This is the first video in the chapter 4-5, it's part of the course, Newton's Laws of Motion. Newton published 3 laws of motion in the, I believe, the 17th century. An object will continue at constant velocity or at rest until acted upon by an outside force. And the second law is net force equals mass times acceleration. The third law is for every action force there's an equal and opposite reaction force. Whenever you're working a problem where you think you're going to apply Newton's laws of motion, it's always convenient to organize the first 2 laws as acting on a single body. The third law involves one body acting on another. Alright, so what I'm going to do in this video is just a very simple application of the second law. So net force means the total of all the forces acting on an object. So in this case, there's only one force, a 9 Newton force, acting on a 5 kilogram block. And so I want to do a unit analysis and a simple application of F equals ma. And since there is only one force, we don't have to bother with the net. So the net is the vector sum. So if there were another force pulling in the opposite direction or pulling in the same direction, we would have to add them, taking the directions into account. And in a one-dimensional world, that's plus and minus. So this is 9 newtons, and the newton is the SI unit for force, and the familiar unit of force in our imperial system is the pound. So there are 4.45 newtons in 1 pound. Alright, so 9 newtons is equal to 5 kilograms times acceleration, and divide. So divide both sides by 5. So 9 divided by 5 is 1.8. And the units are going to be meter per second squared. So let's do the unit analysis, which I guess I should have done before actually solving the problem here. But F equals mass times acceleration. So force is measured in newtons, and you get a newton by multiplying kilograms times meter per second squared. So the SI system unit, the unit for mass, the SI units for acceleration, SI unit for force. So this is your unit analysis. So I know that when I divide newtons by kilograms, I'm going to get my acceleration in meter per second squared, and here's my final answer. So in everyday terms, and exert 9 newtons of force on it by pulling on it with a rope or a tiny rocket engine or what have you, the block is going to accelerate at 1.8 meters per second squared. So this is not the speed of the object, this is the rate of change of the speed of the object, or the velocity, if you want to be, if we're talking about vectors. And not, so 1.8 represents the change in velocity. In fact, to make a connection to the last couple of sets of videos, the 1.8, if this is velocity in time, 1.8 would represent the slope of this line right here.